All right, so next we're going to look at our second method. And so that involves something called the zero factor property, which you may or may not remember from algebra. So we're going to do a quick review. The zero factor property basically says if you have two things multiplied together, so two factors, a times b equals 0, then one of those has to be 0. In other words, there's no way that two non-zero things can be multiplied together to get 0. Okay? And logically, if you think about that, that makes sense. To get 0 out of a product, when you multiply, one of those things has to be 0. Now, technically, this is true no matter how many factors I have. So if I have a times b times c times z all the way up to z, one of those has to be 0. The important things to remember about the zero factor property, just like when we were in algebra, is the 0 part, meaning your equation has to be equal to 0. You can't apply the zero factor property if this isn't true. It's not the 2 factor property or the -7 factor property. It's the 0 factor property. The other thing to remember is the factor part. Factor means these things are multiplied together. They're factors. Something times something equals 0. That means we're going to need to do some factoring as we're approaching these problems. Okay, we're going to work through 4 examples using this technique. Okay, for this example, it's nice because this is already factored for us. Notice that we have one factor, one term, times another term equal to 0. In other words, we are ready to apply that zero factor property. The zero factor property says one of these factors, either this guy, cosecant of x plus 2, has to equal 0, or the other factor, this guy, cosecant of x has to equal, minus square root of 2, I can write. Okay. So one of these has to equal 0. Notice that that gives us 2 linear functions, or 2 functions that we can solve. To solve this, I'm going to subtract 2 from both sides. So I end up with cosecant of x equals -2. Now let's think about solving this. To solve this, we want an exact answer, so we're going to think about using the unit circle. Our unit circle shows sine and cosine more easily than cosecant. But if cosecant of x is equal to -1/2, the reciprocal of cosecant, which is sine, right? Cosecant and sine are reciprocals, is going to be equal to the reciprocal of -2, which is -1/2. We're going to use our unit circle to look and see where sine of x is equal to -1/2. So if we look at our unit circle, okay, sine is our y value. So sine is equal to -1/2 here at 7 pi over 6, and also in the fourth quadrant at 11 pi over 6. So our 2 solutions for the purple part of this equation, let me stop sharing so you can see, are going to be 7 pi over 6 and 11 pi over 6. We got that by looking at where sine was equal to -1/2. Okay. All right, let's look at the other side here. We also have the equation that cosecant of x minus square root of 2 equals 0. Adding square root of 2 to both sides gives us that cosecant of x equals square root of 2. Now again, we want an exact answer. We're going to go to our unit circle. To do that, it's going to be easier to write this in terms of sine instead of cosecant. Cosecant is 1 over sine, so I'm going to think about the inverse of this. Sine of x is going to be equal, not the inverse, excuse me, the reciprocal. Cosecant and sine are reciprocals. So if cosecant is equal to the square root of 2, sine is equal to 1 over the square root of 2. I'm going to rationalize that so it's easier to find on my unit circle. Multiplying top and bottom by the square root of 2 gives me square root of 2 over 2. So I'm going to go to my unit circle, and I'm looking now for places where sine is equal to the square root of 2 over 2. So on our unit circle, where is that going to be? Well, here, sine is equal to square root of 2 over 2 at pi over 4. And also, sine is equal to the square root of 2 over 2 at 3 pi over 4. Okay, so that tells me that our original trig equation, cosecant x plus 2 times cosecant x minus the square root of 2 equals 0, has 4 solutions: 7 pi over 6, 11 pi over 6, pi over 4, and 3 pi over 4. Now, technically, I didn't write, and I should have, that we're solving this on 0 to 2 pi. That tells me, 1, that I'm finding my solutions in radians, and 2, that I'm looking for solutions that are kind of in that 1 rotation on our unit circle. All right, let's look at another example. Okay, so here's our next example. 2 sine squared of x minus square root of 3 sine of x equals 0. We're trying to apply the 0 factor property. We have half of it. This is equal to 0, but notice that our left-hand side is not factors, so we need to think about factoring. Okay, the first way to factor is to look at both terms and see if they share anything. Well, both of those, 2 sine squared of x and square root of 3 sine of x, have a sign in them. That's a common factor. I'm going to factor that common factor out. So when I take a sine x out of 2 sine squared of x, I'll be left with 2 sine of x. Minus, when I take a sine of x out of square root of 3 sine of x, I'll just be left with square root of 3. Okay, now we've got factored and equal to 0. So we're ready to apply the 0 factor property. That says either this factor, sine of x, equals 0, or our other factor, this guy, 2 sine of x minus square root of 3 equals 0. Okay? Both of those we're going to solve using our linear techniques. Okay? All right, so here, sine of x. When is sine equal to 0? All right, I'm not even going to go to our unit circle. I'm going to try and remember when sine is equal to 0. Sine is our y-coordinate, so sine is going to be equal to 0 here and here. That is at 0 degrees and 180 degrees. We're going to find solutions for this one between 0 and 360. Okay, so 0 and 180 degrees. And then we're going to solve this other one, 2 sine of x minus square root of 3 equals 0. I'm going to add square root of 3 to both sides to get 2 sine x equals square root of 3. Dividing both sides by 2 gives me sine equals square root of 3 over 2. Let's go ahead and go to our unit circle to look at where sine is equal to positive square root of 3 over 2. So sine, excuse me, is our y-coordinate. So it's going to be equal to positive square root of 3 over 2 here at 60 degrees and also here at 120 degrees. So at 60 and 120 degrees. So that tells me that our original equation, 2 sine squared x minus square root of 3 sine x equals 0, has 4 solutions. 0 degrees, 180 degrees, 60 degrees, and 120 degrees. All right, here's our next equation. 2 cosine squared minus 5 cosine plus 3 equals 0. We're trying to apply the 0 factor property, which means we need to factor this. Now, there are kind of 2 ways to think about factoring this. One, you can do this straight from here. Some people find that a little bit tricky, and they prefer to rewrite this kind of using x's instead of cosines. So I can rewrite this and think of it as 2x squared, cosine squared becomes x squared, minus 5x, cosine becomes x, plus 3 equals 0. I can then factor this. Okay? If this factors, I'll need factors of 2 times 3, which is 6, which add together to give me my cross term of negative 5. Okay? Well, if I have negative 6 and positive 1, negative 6 times, oops, that's not right. Hold on. That's not right. Sorry, my signs were off. How about negative 3 and negative 2? Negative 3 times negative 2 is positive 6. Negative 3 plus negative 2 is negative 5. So factoring this old school, I'm going to break down that negative 5 to be negative 3x minus 2x plus 3 equals 0. And I'm going to factor by grouping, looking at my first two. 2x squared and 3x share an x. Factoring that x out, using the 2x minus 3. These guys share, I'm just going to pull out a negative because then I can get that 2x minus 3 here. That's going to give me 2x minus 3. Notice that now both of these have that 2x minus 3 in common. Factoring that 2x minus 3 out leaves me with x minus 1. So that tells me 2x squared minus 5x plus 3 factors into 2x minus 3 times x minus 1, which means 2 cosine squared minus 5 cosine plus 3 is going to factor into 2 cosine theta minus 3 times cosine theta minus 1 equals 0. Some people find it easier to factor by changing your trig functions to x's to make it look more familiar like algebra. Some people factor right from here. It's fine. Either way, you're going to have to factor. Okay? Now, once we have this factored, notice it's factored and equal to 0. We can apply that zero factor property. The zero factor property tells me either this first factor, 2 cosine theta minus 3 equals 0, or that second factor, cosine theta minus 1 equals 0. Focus on this first one for a minute. Adding 3 to both sides, I get 2 cosine theta equals 3. And then dividing both sides by 2 gives me cosine theta equals 3 halves. Okay. Now, can we solve this? Well, if I went to my unit circle, I know that I'm not going to have any 3 halves on that unit circle, right? We're pretty familiar with what those values on the unit circle are. So cosine theta equals 3 halves is clearly not one of our standard angles, but more than that, this doesn't exist. Why? Well, think about cosine. The graph of cosine is bounded between -1 and 1. In other words, the range of cosine, the values that cosine can take on, go between -1 and 1. This is bigger than 1. If you think about our cosine graph, right, it goes between -1 and 1. This is up here. We can't have cosine be equal to anything up there. Therefore, this has no solutions, at least this half. Now let's look at our other half, because hopefully we'll get a solution there. Otherwise, we just have an equation that has no solutions. That happens. From the other factor, we have cosine theta equals 1. Adding 1 to both sides gives me cosine theta equals 1. All right, I feel good about that having a solution. Where is cosine equal to 1? Cosine is our x value. So if we think about our unit circle, cosine is equal to 1 right here at 0 degrees, or 1 radians, so at 0 radians. So the only answer to this one is going to be 0 radians. All right, for our last example, we have tangent squared plus tangent equals 2. So we're trying to use the zero factor property. So the first thing we need to do is get this equal to 0. So I'm going to subtract 2 from both sides to give me tangent squared plus tangent minus 2 equals 0. Now we need to try and factor this. Again, when we factor, we can rewrite this to be x squared plus x minus 2 equals 0, or you can just try to factor it straight from here. So this would factor into tangent of x and tangent of x. And let's see, we'd have plus 2 and minus 1. So now we have this factored. We have tangent of x plus 2 times tangent of x minus 1 equals 0. Zero factor property tells us that either this factor equals 0, so that is tangent of x plus 2 equals 0. That's not helpful to see. Or the second factor, tangent of x minus 1 equals 0. So let's see if we can solve both of those. All right, let's try this guy. So tangent of x plus 2 equals 0, moving my 2 over, says tangent of x equals -2. Now this is going to be tricky for us to find on our unit circle. But remember that tangent of x, the range of tangent is everything, so it does have a solution. So we're going to come back to that one, and let's look at this guy instead. Tangent of x minus 1 equals 0, says tangent of x is equal to 1. Well, if tangent of x is equal to 1, that means sine of x over cosine of x equals 1, or sine and cosine are the same thing. If we go to our unit circle real quick, where are sine and cosine the same? Sine and cosine are the same at pi over 4 and also at 5 pi over 4. So our green equation has solutions at pi over 4 and 5 pi over 4. Okay. Now this guy isn't one that we can solve using our unit circle. Instead, we're going to have to go to the calculator. So to go to the calculator, we're going to use our inverse trig function. So to get x by itself, we're going to do arctangent of both sides. So arctangent and tangent are inverses. They cancel each other out. So I'm left with x equals arc tangent of -2. So that's the same thing as inverse tangent. So let's go ahead and go to our calculator real quick and see if we can figure out the solution for this guy. Okay, so here we were doing everything in terms of radians. So let's go back and switch to radians. I'm going to go to mode. I'm going to come down and select radians. Okay, second quit. Okay, so now that we're in radians, we're going to do second tangent. That gives us inverse tangent of -2. Now let's see what we get. We get -1.1. All right, well, here's a little bit of a problem for us, right? We wanted our answers on the interval between 0 and 2 pi. Okay, so how can we take -1.1 and get them on the interval of 0 to 2 pi? Well, in order to do that, we're going to have to add pi. That's going to get us into the right interval. So in this case, adding pi, since we're doing decimal approximations anyway, I'm going to add 3.14. Okay. And that gets us one of our answers, which is 2.03. Notice this is approximate because it doesn't have pi's running around in it. Now there's one more answer because I should have 2 answers for where tangent is equal to -2. To get my other answer, I'm also going to add pi. So plus another 3.14. So again, we're going to have 3 answers just like we did before. Okay. We'll have 2 exact answers. Our 2 exact answers are here at pi over 4 and 5 pi over 4. And then we'll also have 2 approximate answers that we got from using our calculator. And those are going to be at 2.03 radians and also 5.17 radians. Okay, so then we got a little calculator practice as well as practice with solving these trig equations using the zero factor property. Bye-bye.